Welcome to Train Signal. This is the Configuring File and Folder Access lesson in the Windows 7 Administration Training course. In this lesson, you'll learn about how to configure Windows 7 for appropriate file and folder access for your users that enhances security for the GlobalMantic organization. We'll start by talking about how to change file and folder permissions. Then we'll talk about understanding what are called NTFS permissions. NTFS is the new technology file system, and it's the default file system used by Windows 7. With an understanding of what NTFS permissions are all about, we'll then move on to how to assign NTFS permissions to domain users on a Windows 7 domain-joined desktop for GlobalMantic. Because NTFS permissions can conflict with one another, we'll talk about what are called effective permissions. Basically, what happens when you combine different sets of NTFS permissions. Next, we'll talk about the permissions impact of what happens when you copy and move files around the system. After that, we'll move into other protection mechanisms, starting with a talk about the encrypting file system. After that, we'll move on to BitLocker to Go, a way that you can protect portable drives with your Windows 7 system. And we'll wrap up the lesson with a discussion about full disk encryption using BitLocker drive encryption. GlobalMantic needs to provide secure access to files and folders so that users can do their jobs. Because of a recent security incident, GlobalMantic wants to make absolutely certain that the theft of a desktop computer or the loss of a laptop computer does not result in unauthorized access to company data. Now, although GlobalMantic could choose to implement BitLocker on desktops as well as their laptop computers, the company is actually considering using EFS, the encrypting file system, on internal systems just to protect some key shared information. From a business need perspective, GlobalMantic will secure access to files and folders at both the share and NTFS levels. You'll learn about shared folders in the Shared Access to Resources lesson in this course. In this lesson, we'll be discussing mostly NTFS stuff. GlobalMantic also wants to make sure that mobile devices are protected through the use of both BitLocker and BitLocker to Go, and they're going to protect internal desktops with EFS. In the world of IT, there's a security principle that states that users should only have the most minimal permissions they need to complete their jobs. As you add unnecessary permissions to users' permission sets, you increase the likelihood that that user could either intentionally or unintentionally damage the organization. NTFS, which is the default file system used in Windows 7, helps to enforce this least security principle by providing the ability to apply permissions to files and folders in a very granular way. So you can assign to an individual file or to an individual folder only the absolutely minimal rights that are necessary for a user to do his or her job. If you assign no NTFS rights to a user, that user has no rights to that resource. And that's a great thing. Basically, this is sort of a rights of elimination. If you don't have any rights, you can't use the resource. And that's a good thing in a security perspective. With only minor exceptions, files and folders use the same sets of NTFS permissions. But between files and folders, these permissions might manifest themselves just a little bit differently. And we'll talk about all of these NTFS permissions shortly. You can assign permissions directly to a single user. So, you can assign the user named Johnny full access to a folder named Sales. However, it's preferable to assign permissions to groups of users. The preferred method to assign resources is to create a group in Active Directory, a user group, and then assign users to that group, and then assign permissions to that group instead of to individual users. After all, users turn over on a pretty regular basis. If you want to reassign someone resources, it's easier to just add them to a different Active Directory group than it is to actually have to go through all of your systems and redo permissions because an employee left. So let's say you have a sales group, and you have 10 people in that sales group, and then you have across 50 different machines, you've got this sales group assigned with rights to particular resources on those 50 machines. Well, let's suppose now one of the users in that group leaves the organization. You don't have to do anything. All you've got to do is take them out of that group and they have no more access to any of those 50 resources. Now, when that person's replacement comes on board, all you've got to do to give them access to those 50 sets of resources is to add their Active Directory user account into that group, and bam, it's all done. So it makes it a lot easier to manage rights if you use groups than it is to assign rights to individual users. When it comes to the basic NTFS permission sets, here's the ones that we're going to be talking about in this lesson. We'll start with the one called full control, which is exactly what it sounds like. The users assign absolutely full control over the file or the folder, and they can do whatever they want with it, including modify its contents, read its contents and execute programs inside the folder, list the contents of the folder so that they can see what's inside the folder, read information from the folder or read the file, or write information to a folder or modify or create a new file inside the folder. This provides a user with the ability to do anything and everything with a file or folder, including modify its permissions. Full control is the only permission set that allows a user to modify a file and folder permissions. Now what this means though is that if you assign, say, the sales group the full control set of rights, anyone in the sales group can give anyone else in the organization access to that folder. So most organizations do not assign the full control permission set to anyone except actual Active Directory or systems administrators. Instead, they grant those people modify access that gives them everything that full control gives them except the ability to modify permission sets on the resources. So they're still allowed to fully manipulate the files and folders to which they have access, but they're no longer allowed to allow other people to come in and make modifications to those resources. The next set of permissions is called read and execute, and this allows people to list folder contents and read their contents. And again, this allows a user to access a file or folder and to execute any programs that might be inside that file or folder. Now remember before I mentioned that there were some minor differences between file and folder NTFS rights, and that's where we come into list folder contents. This applies to folders only. And that makes sense because you don't have folders in a file. So you have the ability to apply this list folder contents to a user or user group, and this lets them see what's inside a particular folder. The read right allows users to read the contents of a folder or access a file inside the folder. Now, what it does not allow them to do is actually execute the program. They can see files, but they're not allowed to execute programs. So if you store a program inside one of these folders and somebody has read access, they can't actually run that program. The write right allows users to add files and folders to an existing folder. Now, users are allowed to make changes to files when they have the write permission, but they're not allowed to delete files. So they're allowed to do whatever they want as far as it goes, as far as they're concerned with modifying what's already there. But when it comes to getting rid of it, they're out of luck because this write does not allow them to go quite that far. A little bit more about NTFS permissions, and we're going to go over and take a look at some examples on a Global Mantix desktop in just a couple of minutes. But I want to get some other things out of the way before we do that. Next up is called inheritance. Now, inherited permissions are those permissions that are inherited from the parent folder. When you create a new file or folder, by default, this new entity assumes the permission set of the parent folder. So, if the parent folder has security rights that say only members of the sales group are allowed to use this folder and they have the modify privilege, anytime you create a folder or a file inside that folder, those individual files and folders that you create are also going to have that exact same privilege set. No more, no less. This process is called inheritance. And honestly, inheritance can cause very complicated permission issues. So, there is a tool built into Windows 7 that allows you to determine what rights people actually have. We'll be talking about that very soon. But you can also block inheritance and assign unique permissions if you like. So let's say that you create a folder called Shared Folders. And inside the Shared Folders folder, you create folders for all of the departments in the organization. sales, marketing, accounting, and so forth. Now, to shared folders, you allow everyone to have the list folders content access rights so that they can see what folders are there. And that way they can get to their folders if they want to later on. So everyone can see that a sales folder exists, that a marketing folder exists, and that an accounting folder exists. And you give some users other permissions just because they may need access to the full set of folders. For example, your executives. When it gets into the lower level folders, for example, the sales folder, and you start adding, you can add permissions to the sales folder, but all of those parent permissions are going to flow down. So the sales folder is going to start by allowing everyone to see the contents of the sales folder. And then you may add to the sales folder permissions for the Salesforce to be able to modify files inside that folder. However, the marketing group will be able to see every file inside the sales folder, and that may not be desirable. And the only reason they're allowed to see all the files is because that list folder contents permission was inherited by the sales folder. You can actually block this inheritance if you like, and then work on unique permissions. So you can block the inheritance and then say, only the marketing group is allowed to see what's in the marketing folder, and only the sales group is allowed to even see what's in the sales folder. A lot of organizations like to take security to this level because the less information people can see in these organizations, the less that they're going to be meddling in other people's business, I guess, is probably the best way to put it. So, blocking inheritance can be a good thing for organizations that want to make sure that there aren't accidentally too many permissions assigned to certain users. Each and every file and folder on every NTFS permission on every one of the systems you have in your organization has a security tab on its properties page. From the securities tab, you can view the current security configuration for the object, and you can also make changes to the security configuration for the object as long as you have the appropriate permissions to do so. So from this page, this is where you would assign people new permissions to particular files and folders, or remove permissions, or just view the permissions that are there. There's also a command line utility that's called iCackles. This is basically stands for ACL list. That's what ACL stands for. That's what ACL stands for Access Control List. And it's a command line utility that you can use to modify permissions for folders and files as well. GlobalMantix wants to make a few configuration changes to the security side of the house for a few folders on their systems. They want to allow users that are a part of the marketing group to access a local folder named marketing, and they want to give them modify access so that they can do everything except assign new permissions to that folder. And they're going to use the GUI method or the security tab in order to do this. Next, they want to assign people that are part of the sales group access to a local folder named sales. Again, they want to give them modify rights, but they're going to use the command you see on your screen to assign those rights using the iCackles command line tool. Finally, GlobalMantix wants to deny access to the sales folder to the marketing group. And we'll talk about why denying rights can be important in just a couple of minutes. I'm now going to move over to a GlobalMantix desktop machine, and we're going to go ahead and take care of these three tasks. And here we are over on a machine named GM7075, as you can see at the top of your screen. And if I go to the Start menu and open up the computer object, you'll notice I have a C drive and an E drive. I'm going to open up the C drive, and you'll notice there's a folder here called Marketing. I'm going to right-click that folder and choose Properties. And on the Properties page, I'm going to go to the Security tab. You'll notice on the Security tab, there's an Authenticated Users, System, Administrators, and Users folder. Now you'll notice these are local user groups, GM7075, and they don't show that they're domain users. But there's nothing here that says marketing. But we can easily rectify that, and we're going to. I'm going to click the Edit button, and I'm going to click on the Permissions for Marketing window that pops up, the Add button. This opens up a screen entitled Select Users, Computers, Service Accounts, or Groups. And you'll notice that it says select these particular object types from this location, globalmantix.com. What that means is it's going to pull user accounts and groups from the domain, not the local computer, which is what we want in a domain type environment. If you want to change this to pull accounts from a local computer, simply click Locations and then choose the local computer instead. I want to assign rights to the marketing group, so I'm going to click Marketing and click Check Names to make sure that I've typed it right. If it gets underlined, then I have typed the name right, and I can click OK. Now, you'll notice that the marketing users are highlighted right here, and they exist now in the upper pane of this Permissions for Marketing window. But if I look below, they don't have Modify control. When you add a new entity to a permissions list, by default they get Read and Execute, List Folder Contents, and Read Privileges. Now you'll notice that Read and Execute are pretty similar. Read allows people to simply read the contents of a folder, while Read and Execute allows them to both read the contents of a folder, read the individual files in a folder, as well as execute any programs that are in that folder. I, however, want to provide the marketing group with Modify access as well. So I'll choose the Modify button under the Allow column and click Apply. And now you'll notice that the users that log in from the marketing group will have the full Modify privileges to take a look at the contents of a folder and be able to manipulate the contents of a folder as well. Now I'll just go back to make sure those really took. And when I click Marketing, you'll see that there's a Modify with a check mark in it under the Allow column. We're going to talk about the Deny column soon. Now, if we take a look at the Sales folder, you're going to notice that the Sales group doesn't have any rights to this folder. Well, we're going to go correct that right now. I'm going to do this from the command line, however. So I'm going to go to the Start menu, right-click Command Prompt, and choose Run as Administrator. In the Run as Administrator window, or the Administrator command prompt, I'm going to type iCackles C:\sales, the full path of the folder to which I want to grant the access, /grant to say I want to grant these rights to this particular user or this user group, GM\sales. In my domain, GM is the short name for GlobalMantics, or the NetBIOS name. So if I had just called the NetBIOS name GlobalMantics, I would type GlobalMantics\sales instead of GM\sales. Object inherit. This allows permissions to be inherited from the parent. Container inherit, basically permissions to further permission sets to be inherited from the parent container to the object we're working with. And then M for modify. And when I hit enter, I'll get a note that says it processed a single file called C\sales, successfully processed one file. Now if I go to here, back to the C drive, and I right-click Sales now and choose Properties and go to the Security tab, there we go. The Sales group has now been added to the permission set that you see below, and it has Modify, Read and Execute, List Folder Contents, Read, and Write permissions. And this is a good thing. This is what we were hoping to accomplish. We wanted to assign the Sales group permissions to the Sales folder on the system. While we're here, GlobalMantics has a problem. The marketing people keep getting too involved in the sales process. So the sales people have said, I don't ever want them in any way, shape, or form to be allowed access into this folder. I want to deny them access to the sales folder. That becomes important, and we'll talk about that in just a couple of minutes when we talk about effective permissions. So we're going to actually make the change right now. We are going to add the marketing group to the sales folder, but with denied permissions. So let's do it. We'll click the edit button, and I'm going to add marketing. And we'll click check names. And it works, so I'll click OK. So here's marketing. We're going to deny them across the board. We're going to take away every permission that they have, and then click OK. Now, take a look at this warning. You are setting a deny permissions entry. Deny entries take precedence over allow entries. This means that if a user is a member of two groups, one that is allowed a permission and one that is denied the same permission, the user is denied that permission. Do you want to continue? What this means is deny always trumps allow. As soon as a user is denied a permission, anywhere along the line, they are denied that permission, period. Even if they're allowed that permission by virtue of some other membership. So let's say we had a user that was a member of both the sales and marketing groups here. The fact that we've denied this permission is going to mean that that user does not have access to the sales folder. And that's an incredibly important thing to understand when it comes to NTFS permissions. Deny always trumps allow. So keep that in mind. And when we click yes, we're going to see that sales has allow, marketing is denied. Now, we just touched on what are called effective permissions. NTFS permissions can and do collide with one another from time to time. For example, you just heard that I said if a user was a member of both of those groups, the sales and marketing groups, the fact that we denied the permission to the marketing groups is going to mean that the user does not get access to the sales folder even if they're a member of the sales group in Active Directory. But that also has some other implications. Take this for example. A user may have been directly assigned read rights to a particular folder, but also been assigned write rights by virtue of a group membership. So you may have assigned a user directly to the user account the ability to read a folder, but then they're a member of a folder, of a group, that has the ability to write contents to that folder as well. NTFS permissions, with one exception, are cumulative. So what that means is in the case above, the user would be granted both read and write privileges to that folder. That means they could read it, they could write it. The exception is if the user has been denied the rights anywhere, the deny write trumps everything else. And now the user could have been directly denied a right or denied a right by virtue of a group membership. It doesn't matter. As soon as the user has a deny right anywhere along the line, that right is gone, no matter what has allowed them to have that right in other groups. This gets into what are called effective permissions, and we talked a little bit before about this whole inheritance thing too. You may have assigned permissions to a user way up the line in the folder chain. Well, those permissions are going to trickle down by virtue of inheritance. In fact, GlobalManTix is trying to figure out why a user named Steve Smith was able to change a document that's located in the accounting folder on the C drive. By looking at the permissions list, it doesn't look like Steve has access to this folder. We're going to use the effective permissions tool to determine what access level this exact user has been granted and determine why he was able to make the change that he was able to make. Here we are back at our GlobalManTix desktop, and let's take a look at why this user was allowed to make this change. I'm going to right-click this document, and I'm going to choose the Properties option. Then, I'm going to choose the Security tab, and we're going to take a look at what groups have access to this folder. Well, I don't see Steve's name there, but we can't be sure that Steve isn't a member of one of these groups for some reason. So, let's try to figure out what rights Steve actually has. We'll click the Advanced button. On this page, you're going to see that there's an Effective Permissions tab. I'm going to click the Select button next to Group or Username, and we're going to type Steve. That's his account name, Steve Smith, right here, steve@globalmantix.com. That's his Active Directory account name, and we'll click OK. Well, look at that. He's got all these rights you see below. Now, if these rights don't look all that familiar, things like read attributes, read extended attributes, don't worry. They are called special permissions. All of the permission sets we talked about, read and execute, all of those permissions are made up of all of the permissions you see below. When you assign someone the modify rights, they're simply assigned a subset of all the permissions you see here. So what it looks like is Steve is indeed allowed to create and write folders, create folders and append data to folders, so add information, write attributes, delete files, read permissions. He's allowed to do a whole lot of stuff that it doesn't look like he would normally be able to do because his user account doesn't specifically appear on the permissions list on the permissions page. I don't see Steve here anywhere. What you're going to find is if you go to Active Directory, Steve is a member of the Modify group. Now, the other thing I want you to see is why this group is allowed to have access that they have. Well, here's why. marketing group was allowed modify rights because the rights were inherited from the root folder. So for some reason, someone assigned the marketing group modify rights to the whole hard drive for this system. And those rights have trickled down through the folder system to that file. Steve is a member of the marketing group. What we're going to do is we're going to block inheritance for this particular folder. So let's go do that right now. So we'll click the Change Permissions button. And now, if you get to the Advanced Security Settings page for the accounting document, actually, we don't want to do it for the document. I apologize. So we don't want to do this for the document. We want to do this for the whole folder. So let's close out of here and go back to the root folder. And we're going to right-click Accounting and choose Properties. On the Security tab, we're going to see that the marketing group does indeed have permissions. And they shouldn't. They flowed down through the inheritable permissions chain and ended up at this folder. So we'll go to the Advanced button and we'll click Change Permissions. Here, we're going to deselect the checkbox that says Include Inheritable Permissions from this object's parent. Now, you're going to get a warning that says, if you proceed, inheritable parent permissions will no longer propagate to this object. Click Add to convert and add inherited parent permissions as explicit permissions on this object. What that'll do is, rather than these permissions being inherited, they'll be directly assigned to the object and no more permissions will be inherited from the parent. Click Remove to remove the inherited parent permissions from this object. Do you really want all of these users having all of these permissions? And notice the only permission that's not inherited right now is accounting. What that means is these are the only permissions that have been assigned explicitly to this object. All of the rest of these are inherited. And click Cancel if you don't want to make any changes. Well, I'm going to remove the inheritance. So right now you're going to see that the only permission that's assigned is to the accounting group. And I'm going to click the OK button. And I'm going to click OK again. And OK one more time. And you'll see that the only group now that has access is accounting. So let's go into this folder now. Oh, I don't have access anymore. So I have to give myself access again. And that brings up a good point. You remember what I said before is if you don't have rights assigned to you to a folder, you don't have rights at all. I'm logged in as a member of the local administrators group. However, because I didn't assign the local administrators group access to this folder, I no longer have rights to this folder. So I'm going to click Continue and I'll get rights to this folder. Only because I'm a domain admin that I'm logged in as. However, if I right-click this folder and choose Properties and go to the Security tab, you're going to see that the administrator user was added explicitly to the list of allowed users because I clicked that button before that said Go Ahead. I am, however, going to add the local administrators group to the list. Before I click the OK button, however, I don't want to be adding this from the Global Mantics area. I want to change the location to GM7075 and click OK. And then I'll get rid of this. And click OK again. And again. Now I can go to the accounting folder with no problems. The reason that works is because the local administrator group includes all of the domain administrator accounts. I'm logged in as a domain administrator, so that local administrators group actually allows me in by virtue of my group membership. Now if I right-click the accounting document and click Properties, go to the Securities page and Advanced and Effective Permissions, and then click the Select button and type Steve again, Steve has no rights. Because I took away that inheritance, his group membership in the marketing department no longer applies. So by blocking that inheritance, I was able to then explicitly assign rights to a user account or to a user group, and then I don't have to worry about what's trickling down through the whole chain. Just when it seems like there's light at the end of the tunnel with regard to NTFS permissions and their complexity, there's another monkey wrench to throw into the works. And that's what happens when you copy and move files around the system. Now you already got to see that file and folder permissions can be dependent on their location in the file system, particularly as inheritance comes into play. However, when you start moving and copying files around, NTFS permissions can get all thrown out of whack. And let's talk about that. When you copy objects to a new location, those objects always take on the permission set of their new location. So if you copy a file from one folder to another folder, and those folders have completely different permissions, the file is going to take on the permissions of whichever folder it happens to be in. Pretty simple and straightforward. However, when you move objects, there's a couple of different things that happen. And when you move, basically what you're doing is a cut and a paste. You're sort of deleting the file from its original location, and you're creating the file in its new location. When the objects are moved to locations on the same volume, so that is, you're going to move a file from one folder to another folder on the same disk, the files will maintain their existing permission sets. So if you move the accounting folder to the sales folder, it's going to actually maintain the permissions of the accounting folder, but it'll be inside the sales folder. And the permissions from the sales folder will not inherit down to the accounting folder. If, however, you move a file or folder from one volume to another volume, from one disk to another disk, they're going to inherit the permissions of their new folder. So if you move that accounting folder from the C drive to a folder on another volume, it's going to take on the permissions of that new folder, just as if you copied that folder. So the only time that permissions don't change when you copy a file or folder or move a file or folder is when you move a file or folder to a location on the same volume. Now, we're going to go over to the GlobalMantix desktop, and we're going to see this in action, and hopefully it won't confuse the living heck out of you. Here we are, back over at a GlobalMantix desktop, and over here on the left-hand side of the screen, you'll notice we have a C drive, and at the right-hand side of the screen, we have an E drive. These are two volumes on the GlobalMantix system. In fact, if I go to the Start menu and go to Computer, you're going to see we have a C drive and an E drive. Now, the reason I did this is because I want to show you what happens when you copy and move files and folders around and between volumes on an NTFS permission and between NTFS partitions. So, I'm going to move this accounting folder and copy this accounting folder to the various locations. But before I do that, let's take a look at all of the permission sets so we can see where we started and where things are going to end. So let's start with the accounting folder. So I'm going to open up its properties page and go to the security tab. And you're going to see here that authenticated users, system administrators, and users have access to this folder. Okay? I'm going to edit this, and I'm going to add accounting. So the accounting group now has access to this folder. Now, that's going to be kind of our identifier, so you can see what happens as we move and copy things around. Now, if we look at the marketing folder, now we see basically marketing other than the other default groups that are there because of the inheritance stuff. So the marketing group has access to this folder. And sales has access to this folder, as you can see here. No other groups other than the built-in groups. But marketing and accounting and sales are separate groups. The only one you see here is sales. On this side of the house, if we right-click marketing and choose properties and go to the security tab, again, there's marketing. And for sales permissions, we have sales. So that's our baseline. Now, what's going to happen? Well, I'm going to start by moving the accounting folder into the marketing folder on the same drive, and we'll see what happens. So I'm going to right-click and drag accounting into the marketing folder, and I'm going to choose Move Here. Now the folder goes away because I've moved it. And when I go into marketing, and I right-click accounting and choose Properties, you're going to notice that accounting still has accounting in the list of users that are assigned access, but marketing's been added. Why? Let's take a look. Marketing is being inherited, and that makes sense. We moved the accounting folder into the marketing folder, right? So it got by virtue of inheritance, marketing added to its permission set. But it still directly has accounting. Notice that's not inherited. That means that this folder has been directly assigned access to the accounting group. So now both accounting and marketing are allowed access into this folder. Now, when we assigned access to the accounting group before, we didn't give them modify access. We gave them the default of read and execute. So that's the permission that carried over when I moved that folder from the accounting group folder, or from the root folder of the hard drive into the marketing folder. I'm going to cancel this out, and I'm going to undo what we just did. And we're going to make sure that the accounting folder still has its same permission set. The reason I'm undoing it, and it does, is so we can do another example. So I basically just showed you what happens when you move a folder on a partition to another folder. It maintains its existing permissions, but it also inherits the permissions from the folder above. Now, if I right-click and drag this into Sales, but this time choose Copy here, let's see what happens. Notice we still have the accounting folder. Well, that's because we copied it. We didn't move it. So I'll go into Sales. We'll right-click Accounting and choose Properties and go to the Security tab. This time, only the Sales group has access. The accounting group didn't come over. And if we go to the permissions list here, you'll notice that there is no accounting group. The reason is because we copied the folder this time. We didn't move it. So that original permission set just went away. And all that the accounting folder was left with was the permission set of the target folder, which gives it the Sales. Now, if we copy this accounting folder, the original, to the other Sales folder on the other volume, we'll do the same thing. And when we open it up over here, we're going to see a similar situation. Sales and administrators have access to the accounting folder. Now, the reason you're not seeing all the other groups and usernames show up here is because I've blocked inheritance on these two folders just for example purposes. So, the Security tab here shows that the Sales and Administrator groups have access to this folder. Accounting does not. Now, if I move the accounting folder, hold on. This time we're going to move it into marketing. So if I move the accounting folder into marketing on another volume, in the shortcut menu, I'm going to choose Move Here, and we open up its Properties page, we're going to see a similar situation. Marketing now has access because we moved it to the marketing folder, but the accounting group has lost its access. And that makes sense because I mentioned before that when you move things between volumes, it's just like copying them. So it basically lost its permission as it should. So as you can see, there's different things that happen. Really, the main exception is when you move items from one area to another on the same volume, they retain their existing permissions and also obtain the inherited permissions from the new folder. However, when you copy things or you move items between volumes, they only take on the permissions of the new location. Their old permission set is cleared. Now that you understand how you protect files, let's talk about how you can go even further, and we'll talk about encryption. The encrypting file system is an addition to Windows 7, and it's been around a little while, that allows users to encrypt individual files and folders on their desktops. Now, we've talked briefly about BitLocker in this course, and we'll be talking about BitLocker much more later on in this lesson. But where BitLocker encrypts entire volumes of data, EFS is designed to encrypt just individual files and folders that exist on NTFS volumes. It's important that I say that it's NTFS because it does not support other file or volume types such as FAT or FAT32. Once a folder's been encrypted, all of the files that are inside that folder are also encrypted, including any files that you add to that folder later on. So as soon as you add a new file to that folder, they're going to be automatically encrypted. Now, the first time that a user actually encrypts a file on a Windows 7 machine, he gets asked to back up what's a newly created certificate. EFS operates on a public key infrastructure basis, which uses a public and a private key pair to protect the files that are being protected via encryption. Now, in order for the file to be opened, you have to have both this public and this private key pair. what's happening when you first encrypt a file is Windows generates a certificate for that user. And this certificate needs to be backed up, because if it's lost, the user will no longer be able to access his encrypted files. So it's important that the user actually does back up these certificates. Now, multiple users can access an encrypted file, but however, the second user that needs to access the file first has to log into that machine, not just somewhere on the network, but that specific machine, and then just encrypt a random file so that they get a certificate generated for that machine. In larger organizations, this is not going to be a tenable situation. So, those kinds of organizations can deploy Active Directory certificate services. This is a public key infrastructure-based add-on for Active Directory. This centralizes management of all of these security certificates. However, designing an Active Directory security certificate service is well beyond the scope of this course and of the 7680 exam. On the exam, you're not going to be asked to deploy or even use an Active Directory certificate service for EFS certificates. And it's well beyond the scope. It's incredibly complex as well. Now, I talked about the fact that if you lose that certificate, you're kind of hosed. But there is some recovery ahead, and that's through the use of an EFS recovery agent. Now, the other thing that's nice is users come and go. I mean, people quit, people get fired. And they may or may not leave in a way that's really all that nice to the organization. Now, you want to make sure you don't lose access to their files. Nothing would be worse than having a user hold your company hostage because of some stupid certificate problem, right? So, before you start encrypting things, you can create an EFS recovery agent. This will allow an administrator to open files that have been encrypted by another user. However, the agent has to be created before users start encrypting files, and it's done from the command line with that command that you should see on your screen, cipher/r:recovery agent. And then it's going to create two files, that one ends in a .cer and one ends in a .pfx. And those are two public key infrastructure files, and those need to be moved off and to save to a secure location. We're going to create a recovery agent in a lesson in just a second, and that will allow later on, if there's a need for an administrator to recover a file if a certificate is lost. We're going to actually create the recovery agent in this lesson. As a stopgap until Global Mantix is able to deploy a full infrastructure capable of centralizing the various user certificates, they're going to teach some internal users how to use these individual machine-generated certificates, how to encrypt files on their local hard drive. Now, the folders they want to encrypt contain sensitive information about the company. In the wrong hands, could lead to another public relations debacle and fiasco, and a number of other superlatives that you can come up with if you like. One of the computers that they're going to be working on shares two users. It's a PC in the controller's office, so there has to be certificates created for both users. In our case, it's an administrator user that works on that machine and a user named Steve, so we're going to create certificates for both of these users. Before we get started, however, we're going to create an EFS recovery agent to make sure that files remain accessible down the line. We're going to start by creating the recovery agent, then we're going to move on and we're going to encrypt the file for both of these users so we can see what happens when we encrypt the file. We're now going to move over to our Global Mantix desktop PC and get underway. Here we are, again, on a Global Mantix PC. I'm going to go to the Start menu, and I'm going to start at a command prompt with administrator privileges. Now, I've created a directory called cert already on this machine, and that's just where I'm going to store the private key, or the recovery key that we create here, the recovery agent. Now, the command I type is cipher.exe/r:recovery agent. Actually, you have to spell recovery right, otherwise this doesn't work. So, once you spell recovery right, press enter. And you're going to have to provide a password to protect the PFX file. This is one of the two files that's going to be created. And you have to type it again just to confirm it. And now you're going to see that there was a certificate file and this PFX file created. This file combination will allow us to decrypt any files that are encrypted on this machine after the fact. If I waited until people had started already encrypting files, this recovery agent would not be able to decrypt files that were created before the recovery agent was created. So this really has to be created first in order for the recovery agent to work fully. If you can do it later on, but if it's better if you just do it first so you don't have to worry about potentially not having access to a file that was created before the recovery agent was created. With the recovery agent created, now you have to actually import the recovery agent into a local group policy so that this recovery agent can be used later on. So I'm going to start the group policy editor by going to start and typing gpedit.msc. That's going to start the local group policy editor as you've seen before in this course. I'm going to expand this window a little bit so we can see it. Now from here, I've got to go to Computer Configuration, Windows Settings, Security Settings, Public Key Policy, Encrypting File System. Now, you're going to notice there's nothing here. So I have to right-click Encrypting File System and choose Add a Data Recovery Agent. And this is going to start the Add Recovery Agent wizard. So I'll start the wizard, as I already have on the screen, and click Next. Now it's going to say only users who have recovery agent certificates can be designated as recovery agents. So we're going to find this CER file that we just created. So I'm going to click Browse Directory, or actually Browse Folders, I'm sorry. And we're going to go to the C drive, Cert, Recovery Agent. It's going to say Windows can't determine if this certificate has been revoked. The revocation function was unable to check the revocation for the certificate. Don't worry about that. That's going to be pretty normal. So we'll say, do you want to install this certificate? Yes. And this is a administrative certificate. And we'll do Next and Finish. And you're going to see here that the certificate was issued to administrator. Expiration date is 6/7/2110, so you've only got 100 years to be able to recover files. And the intended purposes are file recovery. And if you right-click the certificate, there's minor things you can do here, like export it or open it. And you can get properties and other information about the certificate if you want to, but there's really nothing here that we need to worry about too much. In order for this policy to actually take hold, I really should reboot the computer to reload all the policies, particularly if we're going to start encrypting files immediately after the fact. So I'm going to reboot this virtual machine, and we'll be right back. Now the machine is rebooted, and I've opened up Windows Explorer to a finance directory that has a file called Financing Strategy Confidential. This is pretty important stuff to GlobalMantic, so we want to make sure we do this right. I'm logged in as administrator. I'm going to right-click this file, and I'm going to go to the Properties page. On the Properties page, I'm going to click the Advanced button, and you're going to notice right here there's a button that says, or a checkbox that says Encrypt Contents to Secure Data. I'll click OK. And Apply. Now, you're going to get a note that says you are encrypting a file that's in an unencrypted folder. If this file is modified, the editing software might store temporary unencrypted copies of the file. To make sure that the files created in the parent folder are encrypted, encrypt the parent folder. Sure, we're going to go ahead and encrypt both the parent folder and the file. And this is an important thing. We want to make sure that we don't have unencrypted copies of this file laying around. And we'll click OK. Now, notice that this little thing went green. When you see a green file name in Windows on an NTFS volume, that means that it's encrypted. And that's what you can see. That's the encrypting file system in action right there. So this file is encrypted. And if we go to its properties page again, you'll see that it is indeed encrypted, just like it's supposed to be. And there's some details. We're going to come back to this page in just a second. We're going to click the Add button here in a minute, and you're going to see that there's no one else that actually has a certificate. But we're going to take care of that in here in just a second. I'm now going to log off this machine, and I'm going to log back into the machine as the Steve user. And you'll see what we're going to do here in just a second. Now I'm going to send my Control-Alt-Delete to the keyboard so that we can log in as Steve. And we'll log in. What we're going to do is we're going to encrypt a random file of Steve. And the reason we're going to do that is just so we can generate Steve's security certificate. After that, we'll go back over as administrator and we'll be able to add Steve to that list of where we just were, and because he'll have a certificate on the machine. So we'll be able to give multiple users access to this encrypted file. And this is going to take just a second because this is the first time I've logged in as Steve. So we'll just go to Windows Explorer and we'll go to Steve's Documents folder, and I'm going to create just a small file here, just a text document that's called encrypt. And then I'm going to right click this file, go to its properties page, advanced button, encrypt contents, and click OK. And when I click the apply button, it's going to ask me the same question, but I don't want to encrypt the whole thing this time. So I'm going to encrypt just the file. And the reason I don't want to encrypt the whole thing is my whole goal here is just to create a security certificate. And I'll click OK and OK. That's it. That's all I had to do. That's the whole 9 yards. So I'm going to log back off. All right, we're back at the login page. So I'm going to do the Control-Alt-Delete thing here so I can log in. So we'll log in. View full screen so we can see everything. And now that I'm logged in, I'm going to go to the Start menu. I'm going to go to the hard drive that we have this file stored on. Notice the Finance folder is green now because it should be, because the whole thing is encrypted. I'm going to right-click my file and choose Properties. I'm going to click the Advanced button, and I'm going to click the Details button here now, and click Add. Notice there's a username there now, Steve, because he has a certificate on this system. So I'll double-click Steve's name and take a look. Yes, he's got a certificate. There he is. And to share files with other users, select your certificates and click OK. Click OK. Now, Administrator and Steve are both allowed to use this file and access it without having to worry about access control. One of the things I do want to show you is now what happens when Steve does not have an encryption certificate associated with this file. So I'm going to reselect Steve and I'm going to remove him. And we're going to log back in as Steve. So you can see what happens when he tries to access this file. Let's make sure he has access to it first. So we'll right-click the folder and choose Properties. And from a security perspective, we'll actually give Steve full control privileges. So he's going to have full control. He can do whatever he wants with the file, right? With the folder, actually. So I'm going to log out now. And I'm going to log back in as Steve. And I'll go to the Start menu, Computer, Finance, and I'll try to open this document. Access is denied. Steve has full rights to this file, but he can't open it. And that's good. That's the whole purpose. We revoked his certificate from the file, so he's not allowed to open the file. Can he delete it? Yes. Now, there's a reason for that. The reason Steve can delete the file is because he didn't try to open it. So the purpose of the encrypting file system is not to protect the files from deletion. The purpose of the encrypting file system is to protect them from prying eyes. So that did exactly what it was supposed to do. And I'm going to restore this. That worked exactly the way it was supposed to. So that file is unreadable by Steve because he does not have access to be able to read it. You just got through learning about one way that you can configure your system to protect individual files and folders. Now, we're going to move on to ways you can protect system files and folders en masse, that is, on the volume level rather than at the file and folder level. We'll start by talking about a new feature called BitLocker to Go, and then we're going to talk about the full BitLocker disk encryption tool next. BitLocker to Go is really used where you have portable storage tools in use in an organization, such as USB sticks. People often rely on these portable storage devices in order to transport documents between locations. So they want to save their files at work, take those files home and work on them, and then bring them back. Well, while those files are stored on that portable storage device, you have a huge security problem in your hands. Mainly, the files and folders are not encrypted, so if that device is lost, any information that's stored on the device is also going to be able to be gathered up by those with less than admirable goals in mind, potentially, and it could really expose the organization. BitLocker 2Go is designed to protect in this exact instance. It's a new feature that encrypts the full contents of any portable storage device of the USB variety. It doesn't require any special hardware, whereas the full BitLocker drive encryption, with one exception, requires a trusted platform module chip to be installed. BitLocker 2Go does not require this specialized hardware. In fact, devices protected with BitLocker 2Go can even be read in older versions of Windows. Basically, when you install a USB device on an older version of Windows, you're asked if you would like to install the ability to read files from that USB device. And that really makes BitLocker 2Go a pretty ideal solution, since you can't be guaranteed that everyone has the exact same versions of Windows running at both the office and at home. You can use BitLocker 2Go to allow these users to transport files securely back and forth between locations. BitLocker 2Go has a number of local group policies that can help manage the implementation of this feature. Available at Computer Configuration, Administrative Templates, Windows Components, BitLocker Drive Encryption, Removable Data Drives. We're going to go through each of the group policies that are available so that you can understand what they do. GlobalMantic requires that all portable USB storage be configured with BitLocker 2Go to protect the organization in the event that a USB key is lost or stolen. As such, we're going to walk through and set up the appropriate local policies available to enable BitLocker 2Go, and then we're going to encrypt a USB volume. As you can see, I've already navigated to the BitLocker Drive Encryption Removable Data Drives node in the local group policy editor. And this is where we can configure up to 6 policies to manage the use of BitLocker 2Go on this particular system. I'm going to walk through each of the policies one by one and just give you a quick overview of what each one does so that you understand how it can be implemented for GlobalMantic for maximum effectiveness. The first policy reads Control use of BitLocker on removable drives. This allows you to enable the use of BitLocker or disable the use of BitLocker 2Go for removable devices. When this policy is in a not configured or an enabled state, users are able to use BitLocker 2Go. If you disable this policy, you also disable the use of BitLocker 2Go. The next policy is to configure use of smart cards on removable data drives policy. And this allows you to configure and enable the use of smart cards on removable data drives, basically allowing a smart card to decrypt, or not decrypt, but to access the contents of a BitLocker-enabled USB stick. If you disable this policy, a smart card cannot be used in conjunction with a BitLocker-protected USB drive. The next policy is Deny Write Access to Removable Drives. Let me select this so you can actually see what it does. Deny write access to removable drives not protected by BitLocker. Basically, when this policy is configured, you can stop users from using USB drives that are not protected by BitLocker. When enabled, users will have to first protect the device with BitLocker before they can save files to it. The next policy is Allow access to BitLocker-protected removable drives from earlier versions of Windows. In this policy, you can decide whether or not removable drives formatted with the FAT file system can be unlocked and viewed on computers that are running older versions of Windows, including Windows Server 2008, Windows Vista, and Windows XP with Service Pack 2 or 3. The next policy asks you if you'd like to configure the use of passwords for removable data drives. When this policy is enabled, users are allowed to configure a password that meets requirements that you can define, basically that meet complexity settings. And the last option is to choose how BitLocker protected removable drives can be recovered. And let's open up this policy so you can see some of our information. As you can see, when this policy is enabled, it allows you to choose from some options in the lower part of the window, including providing a 48-digit recovery password or saving BitLocker recovery information to directory services, Active Directory basically. Now let's go set up local group policy to enable some BitLocker to go options for Global Mantic. We're going to open up the control use of BitLocker on removable drives option, and we're going to enable this option. Although we don't have to specifically enable it, we might as well just to make sure we're consistent across the organization. And you can see here that there are a couple of sub-options that are found on this policy. One allows users to apply BitLocker protection for removable data drives. This enables BitLocker. The next one allows users to suspend and decrypt BitLocker protection on removable data drives. And that's exactly what it sounds like. Can they stop the use of BitLocker and decrypt the volume? I'm going to leave these at the defaults. The next option is to deny write access to removable drives not protected by BitLocker. I am going to enable this option because I don't want drives to be used at Global Mantic that have not been protected by BitLocker. If I want to, I can also further restrict the use of these drives by choosing Do Not Allow Write Access to Devices Configured in Another Organization. We're going to take a look at how to configure the organization when we talk about the full disk encryption BitLocker later in this lesson. But I'm going to deselect this option for now. Next, I'm going to choose Configure the Use of Passwords for Removable Data Drives. And I'm going to require a password. I'm going to enable the policy and require a password for removable drives. Again, I'm going to leave it at the defaults, allow password complexity, which will allow me to require a complex password on the device. And I'm going to keep a minimum password length of 8. This is the minimum. If you try to set it to something lower, you'll get an error message. And that's the end of the basic policy configuration for BitLocker to go. In order for these policies to take effect, I have to reboot this system, which is going to end by remote desktop connection. So I'm going to do that, and then we'll be right back. And here we are after the system reboot. And what I'm going to do now is actually install a USB device on this system so you can see what happens. As you can see, the first thing that comes up is the fact that I have to encrypt this device using BitLocker before I can use it. Now, if I choose not to encrypt it, I'll be able to open files that are already on the drive, but will not be able to save new files to it. So I'm going to choose to encrypt the drive, and you're going to see that it starts a BitLocker drive encryption wizard here that says starting BitLocker, and it's initializing the drive right now. Now, there's another option that if I go to the computer item, and right-click the storage, I can also choose Turn on BitLocker. So if for some reason this dialog box doesn't come up, that's another way that you can encrypt your device. And here I need to provide a password. Or if I have a smart card, I can use that too. And I'll click Next. And how do I want to handle the use of a recovery key? If you forget this password or lose the smart card, you will lose access to this drive until you are able to recover that password or your smart card. So you can either choose to save the recovery key to a file or print the recovery key. If you're going to print the recovery key, I recommend you save it in a very secure location. Or if you're going to save the recovery key to a file, don't save it on the same desktop that you're using on a regular basis. Save it to a central file server or somewhere else that's separate from the system that you generally use. I'm going to choose to save the recovery key to a file, and I'm going to save it to gm-file. desktop backups. This is the location to which I'm going to save the BitLocker recovery key for GM-7-M-21. That's the name of the machine that I'm on. Recovery key has been saved. Click Next. And am I ready to encrypt this drive? I will be able to unlock this drive using my password. Encryption can take some time depending on the size of the drive, and until it's complete, the files are not protected. This prevents you from getting halfway through the process and having it be interrupted, and therefore corrupting your device. So I'll click this Start Encrypting button to start the process, and you're going to see that it tells me to not remove the drive until encryption begins. I'm going to pause the video while this process completes. As you can see, it's encrypting the disk right now. And we're back, and as you can see, this drive now has a little lock icon on it, meaning it's being protected by BitLocker. If I right-click the item, I can choose the Manage BitLocker option to choose some additional BitLocker settings, including changing the password that's used to unlock the drive, adding a smart card option, saving or printing the recovery key, or automatically unlocking the drive on this computer, which would basically, when I put the drive in later, it won't ask me for a password. If I go to the Start menu control panel, and I look at BitLocker drive encryption, you're also going to see that from a BitLocker to Go perspective, this USB storage device has BitLocker turned on. Although the other drives we have not yet configured for BitLocker, this drive actually is using BitLocker, and it shows in the BitLocker control panel as being on. Now I'm going to pull this drive out, and I'm going to put it back into the system. You're going to notice the first thing that happens is I'm asked to provide a password, and I've got a little gold lock icon next to it. What this means is each time I use this device, I have to provide this password, unless I choose the automatically unlock on this computer from now on option. And once I click unlock, the device then becomes available for my use. Up to this point, you've learned how to configure encryption for both individual files and folders and for removable devices. Now we talk about the grand poobah of BitLocker, and that's full disk encryption of the actual internal hard drive that you're using on a day-to-day basis. And that's exactly what BitLocker provides. It provides you with full disk encryption that makes data inaccessible unless specific conditions are met. And the conditions are dependent on which BitLocker operating mode you choose in which to operate under. And we're going to talk about the 5 BitLocker operating modes in this lesson. They're TPM only mode, or Trusted Platform Module only mode, TPM with startup key, TPM with PIN or personal identification number or password, TPM with PIN and startup key, and BitLocker without TPM. TPM only mode is actually 100% transparent to the user. It protects the boot environment from modification, and in TPM only mode, there's no requirement for the user to provide a PIN or a password at boot time, nor does the user have to use a startup key, which is a USB device, at boot time. This is the least secure BitLocker option because anybody that turns on the computer can access its contents. The only thing this protects against is the hard drive being taken out of the machine and taken to a different computer. However, if the laptop is stolen and it's turned on, as long as the user is able to somehow log into the machine, they're going to be able to access the contents of the hard drive. So this is somewhat difficult to justify from an implementation perspective because it's really going to be relatively insecure, although it's better than nothing. The next option is TPM with startup key, or between the combination of a Trusted Platform Module with a startup key, you enable a secure encryption on the local hard drive. This is not very transparent to the end user because they have to actually insert a USB key into the computer at boot time. There is no requirement for the user to use a password at boot time, however. They just have to use the USB key. Now, this USB startup key is a USB drive that has been pre-configured for use with BitLocker. This option is more secure since there's a need for the user to do something. They don't have to just turn the computer on. They actually have to use some kind of a physical device in order to boot the system. Arguably the most popular BitLocker encryption mode is TPM with PIN. This is transparent to the user after boot time. This also protects the boot environment from unauthorized modification. And there is a requirement for the user to do something at boot time, namely to enter their password or a PIN. There is no requirement for the user to use a startup key at boot time, however. Again, this is more secure than TPM only mode because the user has to have some kind of knowledge before they're able to boot the system. And finally, it's the most secure BitLocker mode, TPM with PIN and startup key. This is not very transparent to the user at all because there's a requirement that the user provide both a password and have a hardware key available for boot. And now we're on to the first and only modes that will operate without TPM. Now, not every system ships with a Trusted Platform module, so that BitLocker can use that Trusted Platform module on which to store its encryption keys. In these cases, BitLocker can be configured to just use a key device, such as a USB key, to store all the encryption information. Under this mode, BitLocker itself is not able to provide protection for the boot environment because it's not using TPM. However, organizations may still want to use BitLocker even if they don't have TPM because it provides better protection than not doing anything. Again, this mode requires the use of a USB-based startup key that can be lost, so be careful. To enable this mode, you have to modify this group policy object and enable additional authentication as startup. GlobalMantic uses desktops that are enabled with TPM. In particular, their mobile computers, their laptops are enabled with TPM. So we're going to enable BitLocker with TPM for GlobalMantic. So just make note of the fact that you can use BitLocker without TPM, but GlobalMantic has chosen not to do so. And now for some general BitLocker notes. When you use BitLocker in conjunction with TPM, which is by far the preferred method, the encryption key is stored on the system's local TPM chip. It may come a time when you have to recover for some reason. For example, suppose the TPM chip was damaged or cleared by mistake, or the user forgot his or her password, or the USB device that uses the startup key is damaged. In these cases, you can make sure that data remains accessible through the use of recovery information. This recovery information can be stored centrally in Active Directory through the configuration of a Data Recovery Agent user account. The Data Recovery Agent information is configured at the group policy that you see on your screen. We're not going to do that in this lesson. However, it's important to understand that Data Recovery Agent capability exists. Now, the other thing that's important to understand is that any volumes that were encrypted before the creation of the Data Recovery Agent are not necessarily included in the capabilities for the Data Recovery Agent to recover. In these cases, if you have an already encrypted drive, use the manage-BDE, which is Managed BitLocker Disk Encryption command, set identifier, volume letter, for example, BDE-set identifier C, that will enable after the fact Data Recovery Agent support on that particular volume. As I mentioned, there are times when BitLocker needs to be used in some kind of a recovery mode. The contents of the Trusted Platform module chip may have been lost or erased. Or you modified one of the boot files. Either you modified it or some other program tried to modify it. But in either case, it's going to result in a BitLocker problem and you need to correct it. As a best practice, you should temporarily disable BitLocker before you modify any of the system boot files. Another case in which you'll need the recovery mode is if you've connected a BitLocker protected disk to a different computer. When you're in recovery mode, you need to provide one or both of the following: the BitLocker PIN or the BitLocker key that holds the recovery key, the USB key that holds the recovery key. Basically, in recovery mode, you're able to recover whatever key is being used to encrypt the contents of the hard drive. And that's the key factor here. It's the key that's used to encrypt the contents of the hard drive. Therefore, you still have to provide the authentication information, including the PIN and the USB key, And that's going to basically unlock the volume for your use. There's also a command that you can use from the command line to manage BitLocker disk encryption. The manage BDE command helps you manage BitLocker options from the command line, including getting status information by typing manage-BDE-status. You can also do a number of other functions using the manage BDE command. One of the ones we saw before was the set identifier option that allows you to apply an after-the-fact created DRA to a particular volume. For GlobalMantic, you're going to enable BitLocker on a system volume for a particular laptop in the organization. And we're going to use the PIN option, not the USB key option, for the startup authentication mode for BitLocker. And here we are back on our laptop computer that's equipped with a TPM chip. And I've opened up the local group policy editor to the BitLocker drive encryption node so you can take a look at some general BitLocker drive encryption policy options. As you can see right now, they're all set to not configured, which is, with the exception of one policy, is where I'm going to leave them. I'm going to change the unique identifiers for my organization, however. By choosing to do this, I'm limiting what kinds of volumes can be used in my organization to those that have been encrypted by my organization. So if somebody from Acme Incorporated tries to bring a BitLocker encrypted disk to GlobalMantic, that disk will not work. So I'm going to enable this option. I'm going to type GlobalMantic. And then what allowed BitLocker identifications are you going to allow? You may have subsidiaries or something that you need to apply additional BitLocker identification fields so that you can allow them into the organization. Well, I'm just going to use GlobalMantic. You're going to notice at the very top of the options here, there's three folders: fixed data drives, operating system drives, and removable data drives. It used to be that BitLocker couldn't protect everything and anything under the sun, so Microsoft has made a few changes to the group policy options now that BitLocker can protect any storage volume in Windows. If you open up the operating system drives item, there are the 6 policies that you can configure against operating system drives. You can require the additional authentication to startup. Basically, this policy setting is applied when you turn on BitLocker. How do you want to enable additional authentication at startup? Well, if you enable this, you can allow BitLocker without a compatible TPM, which we're not going to do. And you can configure TPM startups, allow TPM, require TPM, or do not allow TPM. Remember, you may not have computers across the organization that have TPM chips, so be very, very careful about the settings you apply. Next, how do you want to configure TPM startup? Allow startup PIN with TPM, require it, or do not allow startup PIN with TPM. The same goes for startup key and TPM key and startup key. This allows you to set a baseline so users can pick and choose what options they use on their own. The other thing to keep in mind is there are some additional options that are for older versions of Windows. Require additional authentication to startup. This is a Windows Vista and Windows Server 2008 policy that's largely overwritten by the new policy of the same name. But before you get started, the first thing you need to do is work with TPM itself. So I'm going to go to the Start menu, Control Panel, and I'm going to choose the BitLocker Drive Encryption option. And you're going to see in the lower left-hand corner of the screen here, there's one option that says TPM Administration. And this starts the Trusted Platform Module Management Console on the local system. And you're going to see that there's not much going on right now. In fact, the TPM chip in this computer hasn't even been initialized yet. The first option I'm going to choose is to initialize the TPM chip by clicking the Initialize TPM option. And it's going to tell me to follow these steps. I have to turn on the TPM security hardware. So I have to restart the computer using the button below, follow the instructions, and then log on to Windows to continue the wizard. So I'm going to click the Restart button. You're not going to be able to see these options because I'm not running this in a virtual machine. So I'm going to go take care of those steps, and I'll be right back. Although you can't see it on the screen right now, what I'm seeing on my laptop screen at boot time is that the following configuration change was requested to this computer's TPM. Enable, activate, and allow a user to take ownership of the TPM. I can press the F1 key to accept it or the F2 key to reject this change. Because I've obviously asked for this option to be enabled, I'm going to hit the F1 key on my keyboard to enable the TPM module on this laptop. And now the system is rebooting again now that the TPM module is activated, and it's going to reboot into Windows, at which point the wizard will restart, and that's where I'm going to pick up the lesson. Now I've logged back into the system, and you can see that the option we see here is to give us the ability to manage the TPM security hardware. The first thing we have to do is create a TPM security password, an owner password for this particular module. Well, I'm going to allow the wizard to automatically create a password for me, so I'll click automatically create a password. And here we go with an option to save this password. Now this is a very long password, but it's a recovery password if we need it. So I'll save the password to a USB device. I'll save it to the removable disk that I need to make accessible first. This disk is protected by BitLocker to go, not TPM. And I provided its password, and I'll click unlock. Now that disk will be usable. And the file name will just be the machine name. And then I can click the initialize button to initialize the TPM security hardware. And it takes just a second, and then it's been successfully initialized. Any applications that take advantage of TPM can now be enabled, and that includes BitLocker. Now, let's go over and encrypt the drive. I'm going to go to the Start menu, choose Computer. I'm going to right-click the local disk, and I'm going to choose Turn on BitLocker. And BitLocker is going to verify that it can actually encrypt the drive, and if it can't, then it's going to tell me that it's going to have a problem doing so. Now, as was the case when we used BitLocker to go, BitLocker also asks if you want to save a recovery key to a file, and I'm going to do that. So I've clicked the Save Recovery Key to a file, and I'm going to save this at Desktop Backups, just like we did the other recovery key. So GM-7-M-21, and I'm going to specify that it's the C drive, and click Save. And it's going to tell me that my recovery key info has actually been saved. And now I'll click Next. Now, do I want to run a BitLocker system check? For every computer model you have, I highly recommend that for every image you have for that model, you do run a BitLocker system check to make sure that BitLocker can actually read and recover all the information that's on your disk before you get started. Now, if you don't run the check and something goes wrong, you could lose access to all your data. So it's important that if you are not sure that you run this check. Now, I've already run the check, so I'm just going to click Start Encrypting. And you're going to see that during the encryption process, we get a little lock here, and the disk goes red. And if I click this window, it tells me exactly how far along the process is. The other thing I can do is go to the command line as an administrator and type manage-bde-status. And I can get information about all of the volumes on my system and their BitLocker status. And as you can see, my C drive is telling me that there's encryption in process. It tells me what kind of encryption method it's using. In this case, it's AES-128. Right now, is it protected? No, because it's not fully encrypted. What the identification field is, it's GlobalMantics. And the key protectors are TPM and a numerical password. Here we have the volume D, which is fully decrypted because we have not enabled BitLocker on it yet. This process, as you can imagine, is going to take quite some time. I'm going to pause the video and we'll come back as soon as it's finished. When the process is complete, you're going to get a message just like the one you see on your screen. Obviously, if you've encrypted a different drive, you won't see the letter C, but you're going to get a message indicating that the encryption process has completed successfully. Now, if we look at our computer icon now, you're going to see that we are back to having some space free. During the encryption process, it sort of looked like it filled up the whole drive, but that was only happening during the encryption process. Right-clicking the drive results in a Manage BitLocker option as well that you can use to manage some of the capabilities of BitLocker. And again, if you go to the Start menu, Control Panel, there is a BitLocker drive encryption option that allows you to have take a couple of different actions. You can turn BitLocker completely off, which will help you decrypt the drive. You can suspend protection, which is what you need to do if you want to make changes to the boot files and not have BitLocker scream at you. Or you can choose to manage BitLocker. One item that we have not done yet is to establish a PIN at Start System Boot. I'm going to go back over to our GlobalMantix desktop now, which is again is an actual laptop, and we're going to enable the PIN option at boot time. I rebooted the system because I made a group policy change that I'd like to show you. And the reason I did that was because I didn't want to bore you with the process we've already gone through a number of times so far in this lesson. So I open up group policy, go to Administrative Templates, Windows Components, BitLocker Drive Encryption, Operating System Drives. You'll notice that the Require Additional Authentication as Startup option is enabled. You'll notice that it's an enabled option and that I've chosen to allow TPM, allow startup PIN with TPM, allow startup key with TPM, and allow startup key and PIN with TPM. So I've basically enabled this option and simply deselected the Allow BitLocker without a compatible TPM. That enables me to execute a command at the command prompt that you're going to see in just a second. I'm starting a command prompt as administrator, and I'm going to provide a manage-BDE command that's going to allow us to provide a PIN for our BitLocker enabled drive. So it's manage-BDE-protectors-add a protector, C, TPM, and PIN. And I'm going to provide a PIN that we'll use as system boot. And you're going to see now that TPM and PIN is enabled. Key protector with ID deleted. So, we probably want to make sure we just be safe and back up our key again, just to make sure that we don't have duplicate keys or keys that have been erased and then reinitialized. So we're going to go back to the Start menu, Control Panel, BitLocker Drive Encryption, and I'm going to manage BitLocker. And notice there's an option here now to reset the PIN. I'm going to save my recovery key again, just to be certain that there's nothing wrong, and I'll overwrite the old one. Oh, I actually won't overwrite the old one. It's not going to matter if you do this or not. I'm just paranoid, so I do it. And click Save. Next. And that's it. Now, if I want to, I can reset the PIN from here as well, but I'm not going to do that again. Now, I'm going to reboot this system again, and I'll tell you what I'm seeing on the screen as I do it. So it's because, again, I can't capture it in a remote desktop session because TPM is a hardware device that doesn't pass through to virtual machines very nicely. So I'm in the process of rebooting my GlobalMantix machine. And the first thing I get up on boot is Windows BitLocker Drive Encryption PIN entry. It's a screen that has that as the title. And it says, enter the PIN for this drive. The drive label is GM7M21C drive. And I can provide the PIN. And once I do that, now here's a couple of other options I see. Press enter after the PIN is typed, or press the escape key for recovery mode. So if I can't remember the PIN, I can press the escape key and move to recovery mode. And assuming that I provide the right PIN, Windows starts to boot exactly as it should. When it comes to file and folder permissions, there's quite a bit to keep in mind with Windows 7. So just make sure you practice over and over. Check all the permission combinations. Make sure you understand what they do. We started this lesson by talking about file and folder permissions. and then making sure you understood what NTFS permissions were all about. And then we actually started going through and assigning NTFS permissions and making sure you got to see the effect of understanding effective permissions. You also got to see the effect of copying and moving files to various places in the file system. And then you got to see encrypting files and folders using EFS, the encrypting file system for Windows 7. We wrapped up the lesson with a discussion about BitLocker to Go and full disk encryption using BitLocker. Thank you for listening, and I look forward to seeing you in the next lesson.